Class, this is Dr. Selby here, and in this video, video 3, I am going to explain how to write names and formulas of ionic compounds that contain polyatomic ions. Here is a list of very common examples of polyatomic ions. You do not need to memorize these examples, but when you're going through writing names and formulas of ionic compounds that contain polyatomic ions, you're going to want to refer to some sort of list. I do want to point out that all of these have negative charges. The most common example of a polyatomic ion is ammonium ion. So when you're looking at chemical formulas, if it starts with ammonium because cations come first, you know it's an ionic compound. So you should be able to recognize ammonium. You recognize some of these probably as being a group of covalently bonded atoms that have an overall charge. For example, in your practice activities, in the last module, you drew the structure of the nitrite ion. So these will be provided to you, but you should be able to recognize them so that you know to refer to your list. So this is some common polyatomic ions that's included on your exam sheet, more inclusive than the list on the last slide. So how do you name compounds that contain polyatomic ions? And it doesn't differ that much from naming other ionic compounds. You still name the cation and you still name the anion. Now, we've seen a couple different cations now. New with polyatomics, a cation can be the ammonium cation. It can be a simple cation from predictable metals in groups 1, 2, and 3A, or it can be a transition state metal that has variable charge. So there's different options. For anions now, we have the common ones that we learned before, belonging to groups 5, 6, and 7A, and now we have polyatomic ions, and many polyatomic ions are anions. So I am just going to circle our cations in each of these formulas. So this is the new one. This is the ammonium one. This is new. And then I'm going to circle the anions. And then we're going to go about naming them. And we just named the cation and the anion. And so for simple cations that do not have variable charge, their name is just their elemental name. So sodium's in 1A, that's simple. But we're going to name that. Let's use blue, since I circled them in blue. Sodium. Name the cation. Now, for the anion, I look on my list. And on the list, if you flip back to the other side, so look at your cheat sheet, we know that that means nitrate. So this is just sodium nitrate. Look on your list again for this one, SO4 2-, that is sulfate. So this is potassium and sulfates. This one's going to take a little bit more work. And the reason is that cation, iron, can have variable charge. It's a transition metal. So iron, don't know the charge. Carbonate, look on your list and you'll see carbonate is CO3 with a -2 charge. So we know that we have to balance this total -2 charge with this charge here, so that there's only one of them, so it has to be a +2. So that's an iron 2 carbonate. And the next one, we recognize sodium, 1A metal. So this is just sodium. And then here, that's phosphate. If you look on your list, you would just see that with the name phosphate. So that's sodium phosphate. And then last but not least, This is a very common polyatomic cation, and its name is ammonium. It's listed on your list as NH4 plus. It's a cation, and its name is ammonium. And then the anion name, look on your list, we see it up here, nitrate. Okay, so that's the guide to naming compounds with polyatomic ions. Let's go the reverse direction. So if you have to write a formula with something with a polyatomic ion, what you should know is that, like in all other ionic compounds, everything is written for charge balance. So the total charge on the cations has to equal the total charge on the anions. Or you could say that the ratios of cations to anions are written for charge balance. In the simple case here, writing charge balance between sodium and nitrate, which exists as an ionic compound, it's just a 1-to-1 ratio, and we just write it like this. However, if you need more than one polyatomic ion to get charge balance, you put that whole polyatomic ion in parentheses to say that it's a full unit. So in magnesium nitrate, you need one magnesium cation for every 2 nitrate anions. And to indicate that you need 2 of these whole things, you put those in parentheses. You don't use parentheses if you only have one polyatomic ion in the formula. So let's get started here. First one, aluminum nitrate. So we're writing formulas. I'm going to go ahead and follow the same method I did before. Aluminum is predictable. It has a +3 charge. It's in group 3A. Copper 1, easy. We're given the charge. It's a transition metal element, and we're given the charge here by this, so that's a +1. Iron 3, again, easy. Transition metal element. Symbol for iron is this. We know it has a +3 charge from those Roman numerals. Lead, symbol PB. This gives us the charge of +2. Ammonium, this is a new one. We have to look on our list, and that's, if you look on the list, NH4 plus. And then sodium, predictable, symbol Na. It's in group 1A, so it forms a +1 cation. So there we have it for our cations. And let's go to our anions. Nitrate from our list we know is NO3 minus. Sulfate from our list is SO4, 2 minus. Hydroxide is OH minus. Carbonate is CO3, 2 minus. Fluoride, that's predictable in group 7A. It gains 1 electron to form the fluoride anion, so F minus. And then phosphate, we look on our list. It's PO4 with a -3 charge. Now we write the formulas for charge balance. So here I have a +3 and a -1. So I'm going to need 3 of these to balance that +3 charge. So it's going to be aluminum. And then I need 3 nitrates. Since I need more than one, I'm going to put it in parentheses. And it's NO3. And I write that 3 as a subscript. So Al parentheses, NO3, close parentheses, 3. Copper 1 sulfate. Balance the charge here. Sulfate is a -2, and the copper is a +1. So I'm going to need 2 of those coppers to balance the charge. So the formula here is going to be Cu2 SO4. On iron 3 hydroxide, we have a +3 here. We have a -1 here. So I'm going to need 3 of these hydroxides to balance that charge of the +3. So it's going to be Fe, 1 of those. I'm going to need 3 hydroxides. So it's going in parentheses, and this subscript illustrates how many there are. So Fe parentheses OH subscript 3. Next one. Here we have +2 on the lead and a -2 on the carbonate. And so in a 1-to-1 ratio, charge is balanced. So that's just PbCO3, no parentheses needed because there's only 1 carbonate. Ammonium fluoride, here we have +1 on the ammonium and -1 on the fluoride. And so in a 1-to-1 ratio, charge would be balanced. So the formula just becomes NH4F. And then last but not least, we have sodium phosphate. Here we have a -3, and here we have a +1. The balanced charges, we're going to need 3 of these sodiums. So this will be Na3PO4. Again, since we only have one phosphate, no parentheses needed. That concludes the lectures on naming ionic compounds and providing formulas for them. If you have any questions, please let me know and send me an email. I hope you have a great day.